Hi. A lot of people have been asking me to model some of these problems, so I am going to pick one problem from each section to model for you. Notice that the front page says to solve using the substitution method. I'm going to show you number 3. So, on the steps that you received, the first thing that it says is to make sure one of the variables is alone in one of the equations. So I'm going to look at these two equations. I don't see anything alone right now, but I do look at the second equation and it says 3y equals 3x minus 21. Well, I notice that everything here divides by 3, so I'm going to do that. And that gives me y equals x minus 7. But that's good because now I can take x minus 7 and I can put it in place of y in the first equation. Again, remembering that substitution means the word replacement. So since y is x minus 7, I'm going to replace that for y in that equation. And when I do that, it will look like 12x plus 4 equals 8, but instead of y, I put x minus 7. Now I can solve that single equation for x. So I get 12x plus 4 equals 8x minus 56. Okay? I've got variables on both sides, so I subtract 8x, and I get 4x plus 4 equals negative 56. Subtract 4, get 4x equals negative 60. Divide by 4, and get that x is negative 15. Well, now that I know x is negative 15, I can use that to figure out y by substituting back into one of the equations. The bottom one already says y equals x minus 7. I want y, so that means that y is negative 15 minus 7. Negative 15 minus 7 is negative 22, which means that my solution is the point negative 15, negative 22. Okay? Okay. I will model number 6, even though I think that was one of the ones you were asked to do. But I know that a lot of times number 6 bothers people. So there's two ways to look at this one. I don't see any variables completely alone. I do notice on the top equation everything divides nicely by 3. But I also notice on the bottom equation that y is almost by itself. I just have to get rid of that minus 8. So if I added 8 to both sides, I would get y equals 3x plus 8. And of course I'm able to move things around because that doesn't really matter. Now that y is alone, I can take all this, put it in place of y in the first equation. So if I did that, it would be 3 times 3x plus 8 minus 15x plus 6 equals 0. And now I would expect, since I got that started for you, that you can finish it. Okay. Number 8, by the way, is very similar to that. If you look carefully at number 8, I don't see any variables alone, but I do notice that this wouldn't be too challenging to do if I just added 2x to both sides. That would get y alone for me. Okay, so I'm going to move on to the elimination method. If I look at the elimination method, or combination is the same thing. Remember that combination method is the same as elimination. Okay. I just have to ask myself a few questions. Is everything lined up? If I look at number 9, it appears that I have x's, y's equals numbers. Number 10 is the same idea. Number 11 is also the same idea. So is number 12. Everything is all lined up for you already. The next thing that you have to ask yourself is, do you see a pair of exact opposites? If I take a look in number 9, I do. In number 10, I do. In number 11, I do not. And in number 12, I do not. So if you do see exact opposites, it's nice. You can just simply add the two equations together. Since I do see exact opposites, I simply add the two equations together. If I look at number 12, I don't see exact opposites. So that's not good. But what I do see is that these are both 1s in front of there. And if I were to take and multiply this top equation by -5, that would make it so that I would have exact opposites. To demonstrate, I would have -5x minus 5y equals -35. Notice that I multiplied everything in the equation by -5. The bottom equation can stay just like it is. And remember, during class I was talking about the idea you have to consider that step ahead. I multiplied by -5 because 1 times -5 is -5, which gives me opposites. I do notice that both the x's and the y's are exact opposites, which means those go to 0, those go to 0, and then -35 plus 40 is 5, 0 plus 0 is 0. I look at that, and I see that both of my variables went away, and I'm left with a statement that is not true. 0 does not equal 5. That means that this is no solution. If I were to put these on the graph, the two lines would be parallel to each other. Okay? It looks like all these on the back are basically the same idea. They're already set up for you generally. Number 15 will require a little bit more, but that's okay. So let's move to the graphs. When it says solve graphically, that means put the two equations on the graph and then see where they intersect. I think number 17 is quite simple, so I'll model number 18 for you. When I'm going to put these on the graph, please remember that you have to have y alone because they have to look like y equals mx plus b. So that's what we should be remembering about lines, is that we need y equals mx plus b. So when I look at number 8, this one already is in y equals mx plus b form. So when I look at that equation, I realize that my slope is 2 and my y-intercept is 8. Okay, so that means that I can put a point at 8 on the y-axis. It might help to label these. So I go 1, 2, 3, 4, 5, 6, 7, 8. Remember that slope is really a fraction of rise over run, so I'll make that a fraction of 2 over 1, which means rise 2 and run 1. And remember that we are always going to run to the right. Okay, and I rise up on this one because the 2 is positive. So from this point, I go up 2 and right 1. Now, of course, I'm out of room, so I'm going to go backwards. Instead of going up 2 and right 1, I'm going to go down 2 and left 1 and put points here, and here, and here, and here. Get enough points where you can see your line being formed. I connect. I draw my arrows. I label. This one was y equals 2x plus 8. Okay? But I do have another line. I have this one right here where unfortunately y is not alone right now. So my objective is going to be to get it that way. To get y alone, I add 16 to both sides. So that will give me 2y equals 4x plus 16. And then I divide by 2 because I still need to get rid of that 2. So I get y equals 2x plus 8. Well, you know what? That looks like the same exact thing as that, meaning that I'll have a y-intercept at 8 and a slope of 2. So if I take a look at this, it appears to me to be the exact same line. Since I did that, think about the fact that the solution represents the point of intersection. So the solution to this particular system of equations, it is actually infinite solutions. These two lines intersect each other because everywhere because they're the same line. The whole point to this, when you're graphing, when you solve graphically, you have to put the two things on the graph and see where the lines intersect. To get them on the graph, get y equals mx plus b for each line. If you have any questions, I'll be here early Monday morning. Please don't hesitate to come and see me. Have a good weekend.